Alright, so the last thing we're going to do in this chapter then is we're going to talk about angles between planes. And this is actually just a very clever uh, manipulation, really, of. Uh, it's a very clever deviation of a regular dot product problem. Actually, this ends up being a dot product problem. So, why is it a dot product problem? Well, let's think of what happens when two planes collide. Right, so I got my plane here, and then I got this plane here that somehow collides with it, right? And then of course it goes through and then down the other side, and the exact same thing happens, yeah, whatever. So it looks something like this. And okay, so when two planes collide, right, they'll intersect on a line here. And what then does what happens to the plane? Well, okay, um, this plane right at this point right here is going to have like a normal that points this way, and this plane right here is going to have a normal that points that way. And what's going to happen is that the angle between the two normals is actually going to be the angle between the two planes, right? So if you think about that for a little bit, it kind of makes sense because each plane has a unique normal, and so the angle between the planes is going to be the angle between the normal vectors of the two planes. Okay, and if that doesn't make too much sense, I guess maybe one way to think of it is because you know how it's because it literally comes from the fact that all planes only have one or two normals. Okay, or all planes have two normals, but if we choose the correct normal, if we always consistently choose like the normal pointing up for both planes, then we're going to get the correct angle. And it actually doesn't matter if we choose the other normal as well, because when you have planes intersecting, uh, let's just say that like a cross section view, it'll look like this, kind of, right? It'll look like that. So this would be like a cross section view of the planes intersecting, and so this angle here is what happens if you choose let's say like one pair of normals, and then this angle is going to be the other pair of normals, and you're going to see that they're the exact same thing by high school geometry. Okay, so again, just if you don't like the explanations, the angle between the planes is equal to the angle between the normals. Just go with it. Okay, and so for example here, 12, 5, 48, you're given two planes, and forgot to pull it up. Okay, you got pi 1 is equal to 5x plus y minus z equals 10, and pi 2 is equal to x minus 2y plus 3z is equal to -1, right? Where pi 1 and pi 2 are just the names of the planes. And so that means I want to find the angle between the normal of the planes, right? And how do I do that? Well, normal 1 is going to be 5, 1, -1, and normal 2 is going to be 1, -2, 3. And now we think, how can I get an angle between two normals? Or how do I get an angle from like two vectors that I know? Well, if we remember, n1 dot n2 was equal to the magnitude of n1 times the magnitude of n2 times cosine theta, where theta is the angle between n1 and n2. And that's exactly how we get the angle of our planes. So we got n1 dot n2 is equal to the magnitude of n1. So the magnitude of n1 is going to be root 25 plus 1 plus 1, right? And so that's root 27. The magnitude of n2 is, I need to erase that line, the magnitude of n2 is root 1 plus 4 plus 9, which is root 13. Okay. And, or root 14, whoops. And cosine theta, right? And so we want to solve for cosine theta. So what we do then is now we got n1 dot n2 over root 27 times root 14 is equal to cosine theta. And that means arc cosine of n1 dot n2 over what we have right now, is equal to theta. All right, and in general, right, this guy in here is written as n1 dot n2 over the magnitude of n1 times n2. Okay? But except we already solved for the magnitude of n1 and n2. I just haven't solved for the dot product yet. So what is the dot product of n1 dot n2? It looks like it's 5, right? And then this is minus 2, and then this is minus 3. That can't be right. I didn't do this. Yeah, 5 minus 2 minus 3. Oh, okay, so it is right. Oh, wow, amazing. So it's 0, right? So this is arc cosine of 0 over root 27 root 14, which is the same thing as arc cosine of 0, okay? And so that's equal to theta. And so essentially, then what's the arc cosine of 0? So for what value of theta do I get the cosine of theta is equal to 0? And we see that theta is going to be equal to pi over 2, right? And that's going to be the angle between our two planes. So you can say that, oh, well, theta could be 3 pi over 2, but that doesn't make too much sense because think about it, right? If you have two planes intersecting, at worst, you could get up to 180 degrees, right? That means they're lying right on top of each other. You can't get 181 degrees intersection because on the other side, you're going to get 179 degrees intersection, which is actually what we're going to say instead. So yeah, so we're not going to choose 3 pi over 2. We're going to choose theta bounded between 0 and pi, and therefore pi over 2 is the correct answer here. So that's how we find angles between two planes. Okay. I said I was going to do another example of something else, but I'm not going to get to it just to save some time. But if you go through the 114 notes that I have posted on my website, you're going to see in the 12.5.4, section 12.5, the relevant exam problems, there's this problem that's a point on a plane closest to another point in space. Right, so it's a relevant exam problem for section 12.5. I highly encourage you guys to look at that, especially understand why the solution is what it is. So take a look at that. This video was angle between planes. I'm not going to cover 12.6 because I fucking hate that chapter. It's super useless. I guess you guys, I'll talk about it in recitation. I'm not going to talk about it in the video. And we're going to move on to chapter 13.